Alright guys, so now that you've had an opportunity to look at the Unit 8 introduction activity, a little bit of an exploration kind of thing for you, to get a feel for what we're going to be doing in this unit. Obviously you guys have figured out by now we're going to be working with quadratic equations and how to graph them. Okay, so before we get into that, alright, let's go over what we're gonna come away with after today's video. Alright, we're going to identify the characteristics of a quadratic function from the vertex and standard form. You guys might remember from yesterday there's two different ways. We're going to get into each of those. Alright, but first let's take a look at this. What do we have? It says, where have we been? Where are we going? Okay, so let's go over a few of the different kinds of graphs that we are already familiar with. Alright, remember one of the ways is linear. If you remember, linear is just going to be constant or steady, going at a constant rate up and down, right? Linear, if you remember, is going to be, if we wanted to write it out, it's going to have an exponent degree. Actually, let me redo that. We're going to write it as mx plus b. And remember this x right here, if it were to have a degree, that degree would be a degree of 1. Okay? And then we also worked on graphing exponential functions, which looked a little something like this, right? Okay, obviously we have had a really big emphasis on what exponents are, what they look like, graphing and whatnot. If you remember these kind of graphs, they looked like that, where the x was the exponent, okay? All right, these were the exponential graphs that we were looking at. Whoops. Okay. So what about when we're graphing a quadratic equation? What is that going to look like? Remember, quadratic is going to have a degree of 2. All right. Your general shape is going to look something like this. Okay. What they've given you here, this shape right here, I'm going to try to outline it. This is called a parabola, okay? That's going to be your general shape of a quadratic graph all the time. Anytime you have a quadratic equation, that's what it's going to look like. Okay, so what are some key characteristics of it, all right? Well, we're going to go through some of the things you looked over yesterday. We're going to officially mark them down in our notes today so you guys can look back at them. And I'm going to color coordinate a little bit for you. Let's start with this one in red, okay? Key characteristics of a parabola. First, you're going to have your axis of symmetry. All right, now I talked a little bit about what that is in the video, okay? But the axis of symmetry, that's going to be where you're going to write it as an x equals some number. All right? It's going to pass through. I'm going to zoom in a little bit so I can write this smaller. Pass through x coordinate of vertex. Remember, the vertex is going to be the highest or lowest point in our parabola. In this case, it would be the minimum. This point right here would be our vertex. Okay, the axis of symmetry is going to be the vertical line that's going to pass right through it. So to stick with the color coordinating aspect of it, I've gone in red. All right, so I'm going to put the axis of symmetry on this in red. Okay, so if it's going through the x value of the vertex, it's going to look something like that. All right? What else do we have? We also have our y-intercept. You guys should be very familiar with this. This is no different than linear or exponential. It is still where it crosses the y-axis. Okay, so in this case that would be, looks like right at, we'll call that, yep, 0,7. Okay, so I'm going to put my little arrow right there. That is our y-int. Sorry, my handwriting has still not gotten much better since moving to this stylus and whatnot, but that's all right. Okay. One other thing that we are going to have when graphing quadratics is also going to be x-intercepts. Pretty self-explanatory. This particular graph does not have one. You'll see it never crosses the x-axis, so there's no x-intercepts on this one. But in any graph that does cross the x-intercept, or the x-axis, I should say, that's going to be your x-intercepts wherever it does cross that. Notice it says intercepts, right? It could be plural, because if you look at the shape of a parabola, it can cross at two different points, right? So you can have more than one. All right. I'm going to get rid of my little circle around the x-axis there. Okay, what else? We're going to go to, do I have like a purple? Blue will work. Okay, let's go to, you've heard me mention the word, but you might not be familiar with what it is. All right, vertex. What is the vertex? Okay, like I said in words, we'll write it down now. It is the max or minimum value of the graph. So the highest or the lowest point of the graph, depending on what kind of graph you have, determines whether you have a maximum or a minimum. In this case, because it opens upward, right, we're going to have a minimum value. Okay, so our vertex is going to be located at the lowest point of it, which is going to be right here. That is our vertex. All right. So this is cool. We got a little bit of color going on. Should make you want to look at your notes a little more, maybe. I hope. We'll see. All right. So that is what the vertex looks like on your graph. Okay, now there are other things we need to look at when talking about graphing quadratics. What are they? Let's see. Can you guys see this yellow? Yeah, that shows up pretty good. Cool. Okay, so let's talk about transformations. All right. You guys have heard this word a lot. All right, but what are they? What does it entail? What are we looking for when talking about transformations? Okay. Transformations could include. Zoom in a little bit because we got a lot to write. Could include horizontal shift, right? That's when it's moving side to side, or left to right, I should say. Could also have vertical shift, or up and down. We could also have vertical stretch. Remember what the vertical stretch implies, how thick or thin its opening is going to be. We learned about those when we were doing our exponential graphs. All right, vertical stretch, and it can also have a reflection. Those are just some of the things we look for with transformations. Those are the primary ones I want you guys to worry about, all right? Other things to look for. I'm going to leave it in yellow because it has to do with transformations. It's just physical characteristics that you guys are going to be looking for, all right? Other ones are, does it open up or down? All right? That just happens to be which way it's pointing. In this case, right, we can see its arrows are going up. We know it's opening upwards. It can also open downwards. You guys will see plenty of examples of that. Other things can also have domain and range, right? That's domain. As far as it's going to go side to side in terms of on the x-axis, right? You did that with exponential, right? Domain was almost always all real numbers in that case. Your range differed a little bit. In this case, it's going to be very similar. We'll get into that. Okay, let's move into the two different forms. How can we write an equation for a quadratic function? Well, there's two ways to do it. Your first one is going to be standard form, all right? That's highlighted right here, okay? So standard form, you're going to be looking for your A term, which is right here, all right? A is going to decide whether it's opening up or down, okay? And we're also going to have the A term identifying the stretch of the graph as well. Okay, and the C term, that one, is going to indicate where its y-intercept is going to be. Hopefully this is sounding a little bit familiar, very similar to our exponential graphs and the way we would identify characteristics from those graphs by looking at the equation. Okay, let's go over to vertex form. This is going to be a little different for what you guys are used to, all right? but it's still going to tell us the same things. How does it do that? Okay, so A, that's going to tell us the same thing. Up and down, vertical stretch. Okay, the vertex is going to be told to us in vertex form, hence the name. Actually, I'm going to make that a different color. Hence the name, right? Vertex form, okay? Vertex is going to be given to us by this H value and K in that order. HK is going to be your vertex, like it says right there, okay? Notice that in the actual equation, however, the H is written out in the regular way. I don't want to say standard form because it's not standard form. I don't want to confuse you guys. It's got a subtraction sign or a negative sign. Notice that right here, right? Okay? So your HK value is going to be opposite whatever the sign inside that parentheses is going to be, okay? So, for example, if this was, let's say, x minus 3 plus 2, the vertex would be a positive 3, positive 2, because it is the opposite of whatever that sign is. It's giving us a negative, right? So if it was a x minus a negative 3, then it would come up as x plus 3 inside those parentheses, and that's not what we have, okay? So it's going to be opposite whatever that sign is. All right. So let's give it a shot. Let's take a look at this first one, y equals 3x squared minus 2. All right. We'll go ahead and write this in standard form. What does that look like? Okay, standard form is going to look like y equals 3x squared, which is what it started out as. Notice in the standard form we're going to have a b value in there, but there is no b value in this equation, right? So we can assume that that would be a 0x. We can assume that b is 0. And then we're going to have minus 4, because they still give us... sorry, not minus 4. Minus 2. Okay, because remember, that's giving us the y-intercept, and our y-intercept, if we look here, is going to be the negative 2. We'll get into that, okay? I've been sticking with red as my axis of symmetry, so I'm going to continue on that. What's my axis of sim? Okay, axis of symmetry. I know there's a second graph here, this one right here. You might have noticed that. Okay, that's just a parent graph. That's going to be y equals x squared. That's just for you guys to use as kind of a comparison graph. That's called the parent graph. You don't need to worry about that. We're looking at this black graph. That is going to be the one of 3x squared minus 2. Okay, this axis of symmetry. Remember, we want to write it as an equation of x equals something. It's going straight down. There's my vertex. This is going through that vertex. That looks like it's at the x value of 0. So I'm going to write it as x equals 0. All right, what about my y-intercepts? Okay, y-int. All right, let's find that. Where does it cross the y-axis? Where does it hit it? All right, well, I could just look at this graph, zoom in a little bit. Oh, sorry. Zoom in a little bit, and I can see at this minimum point right here is where it crosses the y-axis, so it's going to be at the point 0, negative 2. And I can also find my x-intercepts. Now this is going to be one of those cases where there is 2 of them, because notice it crosses the x-axis here and here. So my points for the x-intercepts are going to be 0.816 and 0. Now you might be saying, Mr. Mal, how did you come up with such a weird number like that? I used Desmos to come up with what the x-intercepts are, because it's not perfectly at the point 0, 1. So I'm not going to write it at 0, 1. I'm sorry, 1, 0. I don't want to confuse you guys and get you in the habit of just guessing, because it's not always going to be that perfect. So we'll use Desmos to figure out what the x-intercept is. And don't worry, we're going to get into that at later lessons. All right, what about the vertex? Hopefully you guys remember that the vertex is that high or low value. All right, the vertex in this case is going to be that low minimum value right there. Okay, this one we can zoom in and just take a look. That one's going to be at the point 0, -2. All right, just to stay a little neater, I'm going to get rid of that red, or maybe not. Doesn't feel like going. That's fine. Okay, so we'll leave it right there. All right. What are the other characteristics that this graph has? Some of those transformations we were talking about and other characteristics. It's going to be opening up, right? Notice how it's pointing upwards right here. Both of those sides are going upwards. Its mouth is opening up. Okay, what else? Its vertical shift. That's going to be down 2. Because, right, it was starting where this blue graph is. We're comparing it to that, and it shifts down 2. All right? What else? It's going to have a vertical stretch of 3. I know the number that the stretch is going to have is going to be a positive 3 because remember that one is given to you by your A value. That one is 3, so the vertical stretch is 3. Okay? And my domain, remember that is my X values, so domain, that one's going to be, that one's still going to remain all real numbers. Okay, so that's going to be infinity to positive infinity. However, my range is going to actually have some value to it. That one is going to be -2 as its lowest, and it's going to continue on to, this should actually be infinity, because that one's going to go all the way up. Notice its lowest point is right there at -2, but it goes all the way up, and we have no idea when it's going to stop. So we're going to say that it's positive infinity as the limit for its range. Okay? Okay, how about for this B question? What can we label and identify characteristics of for this graph they've given to us right here, the black one? Remember, the blue one is just our parent graph, okay? So let's figure it out. Let's go through it. What is my axis of symmetry? But I'm trying to abbreviate a little bit because I keep running out of room, okay? So this black graph right here, where am I going to put that axis of symmetry? Remember, it's going to go be a dashed line through the vertex of it. So it's going to be written in an equation form. Now, remember, it's x equals something. If I'm looking at this dashed line, the x value is going to be always, zoom in right there, blocked it by one of my dashes, but it's going to be 4. So it's going to be x equals 4. Okay? Then I'm going to look for my vertex. How do I find my vertex? Remember, that is my maximum or minimum. Right here, also going to be a minimum thing. So I'm going to see where that point falls. Looks like that's going to be at 4, 1. All right? Domain and range, I'm going to put domain as D. All right? Domain is my x value. Doesn't look like there is any limits on that one. So that's still going to be -infinity to infinity, or all real numbers. My range is going to have some numerical value to it. Remember, this is going to be in terms of its vertical limits. So it looks like it's not going to go any lower than +1, but we have no idea when it stops going higher than that. So we're going to have +1 and infinity. Okay, now the reason you might have noticed I wrote the bracket there and a parentheses here, the parentheses is because it keeps going, right? The 1 means it hits this number 1 and stops right there. The 1 means, that bracket means that the 1 is included in the range. Okay? What about the vertical shift? What about the transformations of this graph? Well, if I'm talking about how far to the side it goes, looks like it's going 1, 2, 3, 4. So it is shift right 4, and it's going up just this 1. Okay, shift right 4, it's going up 1. I labeled the vertex there. It's a minimum. I didn't label it for you guys, so I'll do it right there. Okay, so there's your vertex. That's going to be at the point 4, 1. All right. Okay, let's go to C. All right, I've got y equals negative x squared minus 1. Let's go through it. Try to, a little border here, give myself some more room. Where's my axis of symmetry? Remember, that's going to be an x equals kind of thing. Notice that this graph is going to be a little different in the sense that this one is the first one we see that's opening down, right? It's going downwards, so it's a little different, or you might have noticed it is a reflection in a way of the parent graph that they gave us. Okay? Okay, so the axis of symmetry, what's it going to be? Well, that's still not going to change even though it's going down. It's going to be a dashed line going through its vertex, which in this case is going through the line of x equals, that is 0. Okay, there's our axis of symmetry. What about the y-intercept? Is it crossing the y-axis anywhere? It is. It's crossing the y-axis right here. So that is going to be at the point 0, -1. You might also notice that that is the vertex as well. Okay, so I'm going to put a little arrow here and also say vertex. And that one's going to be the point 0, -1 as well. Okay, what about my domain and range? Domain, this one still doesn't look like it has any restrictions on its side-to-side values, its x values, so that one's still going to be all real numbers, or negative infinity to positive infinity. The range, this one is going to be a little different now because its lowest value, well, we can't really tell because it keeps going so far down. All right, that one is not necessarily restricted. So what we're going to label that as is its lowest value is going to be negative infinity because it keeps going in that direction. However, its highest value stops right there, right? That's a terrible arrow. That's all it was supposed to be, was an arrow. It stops right there at its vertex, which we know its value is -1. Now, I actually made the mistake right there. -1, remember, is included in that range, so that is going to have a bracket when we write it. What are some of the characteristics this thing has? Well, we did notice that it is not going in the same direction, so it does reflect over x-axis. That looks like a y, so I'll fix that. Reflect over the x-axis. What else does it do? It shifts down 1. Okay, so now that's what we would do when we have a graph given to us and we want to label some of the characteristics. What about when they give us an equation? How can we identify things without looking at a graph? Okay, well, we can still do it. It's just going to take a little bit of imagination. But remember, those equations tell us things about what the graph is going to do, so we can use those to identify what it is. So before we get started, let's recall a few things from the beginning, okay? And I'm going to write them down here, okay? Remember that the A value, that's going to tell us whether it opens up or down, and if it reflects over the x-axis. Okay, what else should we know? In standard form, okay, the C is the y-intercept. And in vertex form, HK is the vertex. All right, so let's use that stuff and figure out some characteristics of A. Y equals x squared minus 8x plus 7. Well, this does not look like it's in the HK format, so I know that this is going to be standard form. Okay. The vertex, I'm going to rewrite that because that is hard to read. Handwriting's terrible today. The vertex is going to be a minimum y, because the graph is going to be opening up. And we know that because our a value is positive, right? It's not written down, but it would just be a 1, so you know it's a positive. Okay, there is no vertical stretch because our a value is just 1. And because it's just a 1 and it's a positive, there's also no vertical stretch or reflection. And the y-intercept, remember, because this is given to us in the standard form, so our c value is going to be the y-intercept. That is positive 7, so our y-int is going to be 0, 7. All right, now to try and stay a little bit organized, I'm going to do B in a different color. Okay. Actually, we're going to go ahead and skip B. We're going to go to D. Now, D, you can see, is written in that vertex form, so I'm going to label that one vertex form. Okay. How do I tell what the vertex is? Remember, that's going to be HK. My H is this number here, and the K is the value after that. H, comma, K. Remember, when we're trying to find our vertex, this H value is going to be the opposite of whatever sign shows up. So because this is a negative 4, our X value is going to be the opposite of that, which is 4. And then this one, this value here, remains the same sign, I should say. So that's going to be the Y value of positive 5. So there is our vertex. Okay. Does this one open up or down? This one's going to be opening up because our A value is a positive. So it is opening up. Okay, because A is plus 4. What else is it going to be doing? Okay, remember what else A stands for? It also stands for a vertical stretch. Because that number is 4, we're going to have a vertical stretch of 4. All right, how about our domain and range? Okay, remember our domains, we're just dealing with ones that go up and down right now. If I were to sketch this one out, it's going to look something like, my vertex is 4, 5. Let's go 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's going to meet somewhere over there, and it would be opening upwards. So my vertex is 4, 5. It's going to go through that vertex. I missed it, but yeah, we're getting closer. It would look something like that, okay? So domain and range on that one. Domain is our x values. Again, we can't tell the restrictions of the x's, so we're going to keep that one as, sorry, these are going to be the parentheses. Negative infinity to infinity. Start with your lowest first. My range will have some restrictions. The vertex is a minimum, and that y value of the vertex is 5. So the lowest point it's going to get is 5, and the highest is going to be infinity because we don't know when this graph ends. It keeps going up and up and up and up and up and up and up. So we're going to keep it as infinity. Okay? So this was a lot of information for you guys on the first day. However, it's really just kind of learning how to identify characteristics of the graphs you are going to be seeing throughout the unit. All right, we're not really solving for anything. We don't need to figure a whole lot out right now. Don't get overwhelmed by this. Use the color coding that I gave you guys, and just remember what each of those numbers in the equation tells you, right? Our A is going to tell us a vertical stretch. The A is going to tell us also if it's opening up or down. All right. The vertex form is going to give you where the vertex is. Remember what the vertex looks like. That's going to be maximum or minimum value of the parabola. If it's opening up, you're going to have a minimum or a low point. If it's opening down, you're going to have a maximum or a high point. Okay? So just think about that. Use these notes to go through the practice. You're not going to have the practice on the same day, obviously. This was a lot. Any questions, send me an email. Be happy to help you. And we'll be talking to you guys soon.